It takes me a long time to make videos, and part of that friction is editing, and part of that friction to editing is all the keyboard shortcuts I have to remember. To solve this problem, I wanted to build a simple macro pad. But the thing is, buttons, and I mean good clicky buttons, not this junk, are quite expensive. And generally, the keyboard building hobby as a whole is quite expensive. And I have a lot of expensive hobbies. So I wondered, what if you could just 3D print a keyboard? I mean, 3D print the whole keyboard. 3D print keycaps, 3D print switches, 3D print the case, everything. Now I'm going to have to go back a bit on my word. We're going to need a bit of electronics to detect presses, a microcontroller to detect those presses, and finally some screws to put it together. Let's first understand how a regular key switch works. There are three key parts. First, the stem, which is the part that goes up and down. Second of all, there is the spring, which provides the upwards force on the stem. Finally, there's the electrical contacts. It's actually quite a smart design. The stem has a piece which pushes back against the contacts, and once the stem is pushed down, the contacts touch, leading to a registered button press. And obviously there's the outer casing, but that's not too important. My switch is going to need a similar set of parts. Instead of having a separate stem and keycap, I'm going to integrate them into a single piece. Guides on the side of the switch will ensure full depression of the whole key. Now comes the hard part, how do we print springs? We can't just print regular helical springs, so instead I'm choosing to print zigzag springs. These are essentially springs that go back and forth, and you can print these fairly well on a 3D printer and make them quite thin, which is good. The last problem is how do we detect a key press? This is where I'm going to steal something from gaming keyboards. I'm going to use Hall effect sensors. Without getting into the physics of it all, Hall effect sensors can detect the distance to a magnet by using the Hall effect. By putting a magnet on the keycap and putting a sensor inside of the base, we can now detect presses. You are watching the 15th prototype print. At first I thought this would just be a small, quick project to test the limits of 3D printing. I didn't even film the first 14. This was not supposed to be a long-form video. I think I ended up in a very deep, dark rabbit hole. Notice in this prototype that the clearances on the overhang still need a little work. Ideally, the keycaps would come on without the need for a hammer. After cleaning up the print, it actually feels pretty good. However, the travel still needs to be improved. We're at about 3mm of travel, and I'd like about 5mm of travel. While the prototype is printing, let's go over the three key things I'm looking for. First of all, I'm looking for travel distance. Cherries generally have about 4mm of travel distance, so I'd like to get similar. This is actually one of the easiest variables to experiment with because we can just change the amount of space that the keys can go up and down, so I'm really going to leave that experimentation for later. The next thing I look for is consistency. No matter where on the key you press, you should always get the same feel. It should be smooth and there should be no slop. This is actually fairly hard because 3D printers are very inaccurate, and so to get around this, I hand file every single one of the guides on all the key switches to make sure I get as smooth of a click as possible. The last thing we look for is a force curve. Good switches generally have 30 to 60 grams of force, and they should be linear. The more you press in, the more force it takes, and it should create a nice linear graph. You also do have clicky and tactile switches which have more complicated force curves, but for now I'm going to stick with the simplest. So if I can master linear, I can also master the rest. Okay, the print finished. The keycap now presses in more smoothly, but I found the sound was a bit unpleasant when pressing it. I know that wasn't part of my criteria because it's far more subjective, but I think everybody can agree that that doesn't sound very good. I tried putting the switch against different materials, and I even tried adding tape to the actuation area, often called a painter's tape mod in the keyboard community. But that did not improve the sound much. At this point, I had enough prototypes, so I thought I would try working a bit on the electronics. I realized when reviewing the footage that I filmed the following part in slow motion, so enjoy the glamour shots. This only took something like 12 gigs of files. There's a little notation in the switch wall where a Hall effect sensor is pressed in. After looking up the pinout for the 5th time, it's ground, output floating high, and then power. I started it quickly to the ESP32. Software time. Let's get ChatGPT to make this work. Essentially, I'm making the ESP32 could pretend to be a USB keyboard. First I checked that this would work correctly. Boom, first try. What can I say? I'm too good at this, or ChatGPT is too good at this. Anyways, however, as soon as I started trying to use the sensor, everything broke. I first tried to add an LED to debug, that didn't help. I tried to add a serial to debug. Eventually, I realized that the LED logic was just entirely trash, and the ESP32 was plugged into the wrong port. Oops. Anyways, here's it working. Hey, it works now. Look. I printed out the 4 keys I would need to build my simple 2-key by 2-key prototype. I just made the springs a tiny bit thinner to decrease the force. They popped in easily and definitely seemed better. With a couple presses, however, 3 out of the 4 buttons broke. The springs just kept snapping at the joints. At least I have one working prototype. I measured its actuation force and got an average of about 100 with it increasing at the bottom. That's too heavy and not even linear. The force increases far too fast at the bottom. To make matters even worse, my 3D printer broke. It was under extruding and the extrusion force was just far too high. I thought originally it was a clog, but I tried cold pulling and I didn't get any good results. I then tried replacing the nozzle, but that didn't even work either. To make matters worse, the end of the boating tube just came out because I don't even know why. Luckily for me, my grandparents bought me a new printer. This saved this project and all the other projects I was working on. I'm not entirely sure what happened to the old printer. It was 6 years old and things were starting to fall apart. My crankbed at the heating circuit was broken. When I forced the temperature to go up to like 270 degrees Celsius, it would start extruding again, but not really. Anyways, let's get on with the video. The first few prints on the printer looked quite promising. After printing out the obligatory benchy, which looked quite nice, I started printing a key switch. With this new printer, I could print much smaller layer lines, which means I could finally get rid of the need to file down every single key switch, which was nice. I unfortunately still had a problem. The keys were way too heavy. I think part of the problem is what's actually getting me the springiness in my springs is the horizontal beams. What kept happening is it was the cross sections between the beams that kept breaking. By thickening up those cross sections, by thickening up the intersections and thinning out the beams, I could finally get a slightly better spring. I also split the beams in half to decrease the surface area to also increase the springiness. At the same time, I started experimenting with the angle of printing. By printing it either at like 45 degrees horizontally or 45 degrees vertically, I might be able to get slightly better characteristics with the springs, or so I thought. It turns out this was quite hard. For most of the orientations, it required putting supports to support it, since otherwise it'd be printing into thin air, and I couldn't get the supports off under the springs. Enjoy footage of Noah suffering for 20 minutes trying to get the supports off. In the end, I ended up with a couple directions that worked, the directions that didn't require supports, but all of them just weren't strong enough. As you can see, the best I got was 60 grams with this one, but it didn't really work. In the end, I'm just going to stick with printing it vertically. The whole design is designed to print vertically, but I did learn one thing from this experiment. It was that if I used supports, but only for the top part, so not the part under the springs, I could actually help support this print, which led to much prettier springs. At this point, I started printing the enclosure for the 2x2 layout. The first prototype was close, but the switches were a bit too loose, so I printed the second one anyways. I was now ready for the final key switches. I printed out the switches, and then I realized I kept the internal supports. I tried to salvage them, and I ended up breaking every single one of them. Enjoy like 5 minutes of Noah suffering condensed down to 10 seconds. This time, I learned my lesson and printed only one of them to make sure it worked. It fit quite nicely, which I'll take credit for. I then added a drop of glue and pushed in the Hall effect sensor. Unfortunately, it came out, so I re-glued it. I then put in the switch into the keypad, and yeah, I still needed glue. The tolerances have a bit of work still. After taking a short tech break, I realized I could wire up the first switch while waiting. As mentioned earlier, each sensor needs a ground wire, a power wire, and a signal wire. Each ground and each power pin is connected to the next sensor, and the first sensor is connected to the SP32. The signal wires are for now going to separate digital inputs. Now we repeat the process again. Boom, another one done. I repeated this process 2 more times off camera and actually realized that super glue was far better than hot glue to hold down the Hall effect sensor. Next up, the keycaps. Turned out this was harder than I expected because to detect a click, the Hall effect sensors need a specific polarity, and I kept mixing up the polarities of the little tiny 1mm magnets I was using. Eventually, I figured it all out, glued it in, and fingers crossed it works. Now I just need to update the code from earlier to make everything work now with 4 buttons. And it just wasn't working. So I re-soldered all the wires, and it still didn't work. It turns out one of the pins I was using actually still happened to be reserved. And finally, after 3 months of working on what was supposed to be a 2-week project, I finally have my first prototype. It really is a certain amount of irony of editing the video you're watching with my keyboard that I built. It actually works pretty well. I currently have these 2 buttons mapped to trim to the beginning and trim to the end, and then this button to a split. Here, I can show you. There you go. I'm gonna end the video here. I've spent like 3 months on what was supposed to be a 2-week project, so I'm tired. I'm gonna be working on some other projects. They might make it on YouTube, they might not. I don't know. The thing is, I still would like to come back to this. A 2x2 keyboard's a bit restricting. There's only 4 possible shortcuts, and Premiere Pro has a lot more than 4 possible shortcuts. So, you know, if you want to see an update to this, you should like and subscribe. Anyways, that's it from me. Keep on hacking.